So I want to thank you for stopping by this afternoon. My name is Daniel Fisher. I'm an ag engineer with the Agricultural Research Service in Stoneville, Mississippi. My co-presenter here needs no introduction. Mr. Bubba Simmons has been featured lately in the media, and I'm sure that's why you all came here to see him. But I'm sure you've been to rock concerts. You know how these things work. You pay your money, you want to see the star attraction, but you got to endure the warm-up band first.
Opening act. Opening act.
Bear with me a couple minutes, settle in, warm up, and then we'll get to the star. So I'm going to talk a little bit about irrigation scheduling and some of the work we're doing with water management. You know, this is a hot topic these days. There's water problems everywhere. And things are changing in the world, rainfall and water supplies. So water is a valuable resource that really needs a lot of attention. So irrigation has been around for a long time. People have been irrigating for a variety of different reasons, different motivations. You know, a while ago, when inputs were cheap, fertilizer was cheap, fuel was cheap, people would irrigate to get a maximum yield. You know, do whatever they can, apply whatever they can to get a maximum yield, but that's not the way it is anymore. Prices have gone up, all of our inputs are not unlimited. So we need to change some of the ways we're doing things and make things more efficient. Nowadays, agriculture is just like any other business. You gotta make money to stay in business. You all know, you gotta make a profit. I work for the government, and we don't deal in profit. These days, now that I think of it, this is being recorded, I probably shouldn't have said that. We'll get them to edit that out. But agriculture is a complex system. There's a lot going on when it comes to water. There's a lot going on with the different crops. The water use is different for different crops. The water use changes throughout the season. Things vary from year to year. So you can see these water use curves, they look a lot different from different crops. You've heard, you know, we've all heard, if a little bit is good, then a lot must be better. And with water, that works up to a certain point. Now, if you're not irrigating, if you're rain-fed agriculture, you can expect some yield. And you add some water, you get an increased yield, you add more, your yield's better, but you reach a point where no matter what you do, it's not going to increase yield, it's probably going to decrease yield. And the same with profit. You add inputs, you get more yield, you get more return up to a certain point, and then you throw in more. So we need to find better ways to manage all of our inputs, but water in particular, since that's what we're talking about. So brings the idea of irrigation scheduling. So a lot of times there's a misconception when someone says irrigation scheduling, they think it's something complicated, and no, it's just using information to make better decisions. Doesn't have to be time consuming or complicated, it's just what kind of information can you use to make better decisions. So there's been surveys done over the past and to see what types of tools people are using. What kind of information do they use to decide when to irrigate? A lot of them are pretty subjective. You look at the crop, you look at the soil, what's the guy down the street doing. There are a lot more objective, more scientific methods that basically have not been adopted. And so I'm here to talk about these things that nobody ever uses. But hopefully, you know, this is going to be a real broad overview, nothing too detailed or involved. Just, you know, what can you do to help make better decisions? So that a lot of the scientific, more objective methods can be divided into two groups. Sensor-based instruments, put sensors out, you monitor what's going on in the soil or the plant, or weather-based models. A lot of computer models that try to mimic or estimate what's going on out in the field. So first I'll touch on some of these sensor-based methods. There's a lot of different sensors, a lot of different electronic equipment, that you can get. And there are advantages and disadvantages to using these sensors. One of the main advantages is you put these out in your field and you get a good idea of what's going on in your field. But the disadvantage is, well, it costs money to buy this equipment and some time and effort to install it and maintain it. And then, well, this localized information can also be a disadvantage. If you know a lot about what's going on in that field, well, it may or may not tell you much about what's going on in a different field. Now, a lot of the sensors that people use are moisture sensors. They monitor what's going on in the soil root zone. And there's two basic types. The water potential, or the water tension, is a measure of how hard the plants need to work to extract the water from the soil. And these work pretty well in most soils without any calibration. The other type of sensor that's more common is the water content. And these tell you how much water, or give you a measure of how much water is in the soil. But these are very soil specific. Now these two properties, the water potential and the water content, these are the main water holding characteristics of the soil. And the good news is they are related. For every soil, these properties are related. The bad news is they're unique for all the different soils. So here's a couple examples of what these relationships look like. If you have a sandy loam soil, your relationship might look something like this. But if you've got a sandy clay, it looks a whole lot different. So this green box here, this would be the range that we would usually irrigate if we were using these water potential sensors, between 50 and say 90 centibars. But if you're using a water content sensor, which soil do you have here? So if you put a water content sensor out in the field and you got a reading of say 0.27, if this is your soil, 0.27 would be about here. Looking at the tension, it's pretty low. That means the water's freely available. There's a lot of water in the soil. You don't need to irrigate. But if you had a different soil, 0.27, well, that's way out here somewhere on this other soil. You should have irrigated a couple days ago. So water content sensors are good. They give you a lot of useful information, but there's a little bit more work involved to be able to use the numbers that it gives. So if you want to use some sensors, there's a couple issues that you need to deal with, some things you need to consider, some questions to answer. What kind of sensor you're going to use, how many, where you're going to put them. And this will depend on a lot of factors. What's going on in your field, your soils, the variability, irrigation system. A lot of times the first question is, well, how many sensors do I need to put out there? At each location, how much of the root zone should I be monitoring? So the consensus among irrigators, people that work with this, is 3 is probably good. You put some near, this is normally how I do it. And we put some near the surface, because if you look at the root distribution, a lot of the roots, almost half of them, are in the top quarter of the profile. If we put another sensor a little bit deeper down, in the top half of the soil, 70% of the roots are there. This is where they get most of the water. But we also put some down deep because there is root activity deeper down. And then, how many places do you need to put out in the field? How many different sites do you need to monitor? Well, this is going to depend on what's going on in your field. If you had a field like this, in each of these different colors, it's some variability out there, most likely due to soil. You're irrigating, here's your poly pipe, and the water runs this way. So how do you decide where to put your sensors? There's different strategies that people use. Maybe you want to do it based on the lowest water holding capacity soils, or sandier soils. These are going to dry out quicker, so you probably need to irrigate those quicker. But if you're irrigating those and you turns out you end up irrigating more frequently, what happens in the rest of the field? Maybe it's going to get too much water. Other people would say, well, use the predominant soil type. You know, this one here is the biggest part of the field, the most crop affected. Maybe that's where you should be monitoring. Or other people, well, look at the yield potential. Where is the best part of your field? Where can you get the most yield? Where can you get the most profit? So how do you decide where to monitor? You know, ideally, you'd monitor the whole field. If you've got different zones, put some sensors here, put some here, put some here. That way you're looking at the whole field and you're getting information about each of those different areas, and then you can decide how you want to irrigate. Which leads to the next step. Now, if you're monitoring each of those different zones, can you treat each of those zones independently? Precision irrigation. You might need to modify your irrigation setup a little, add some valves here, maybe some extra poly pipe. But if you can identify zones in your field that behave differently, can you treat each of those differently? So instead of dealing with one big field with a lot of variability, now you're dealing with smaller areas that you can manage better, give those the inputs they need, and try to maximize your output. I use a lot of sensors. We put sensors in all our fields, but I also like using scheduling models, computer models. One of the main advantages for me, I'm lazy. Not a lot of work involved. I have to put a lot of sensors out. Do it all on the computer in the air-conditioned office. A lot of a lot of states all over the country, they have developed their own scheduling models for the local conditions. So Arkansas, Tennessee, Mississippi, Missouri, they've got scheduling models for those states. Extension people are familiar with those, and they can offer some help with those. But there are disadvantages with these. You know, they're theoretical models, mathematical equations. Sometimes there's information that's needed that you may not know, or it's kind of hard to find. You have to estimate it. So these models try to just keep track of what's going on with the water out in your field. You've got the main components here. Water's leaving the field. You've got water coming in. These models just try to keep track of what you have in the soil. Like checking account, look at your deposits, your withdrawals, and then you try to ensure that you have enough when you need it. So early in the season, you know, the crops don't need much. Maybe a tenth of an inch a day. So after a week, you know, it's used less than an inch. Early in the season, a lot of times we get the rainfall, don't need to irrigate. But around the peak time, you know, a quarter of an inch, a third of an inch a day, so that's 2 inches a week. You get 2 inches a week in rainfall. If not, you might need to start thinking about irrigating. So the water balances, it's usually just a simple equation. What goes in, what goes out. If you want to know what the conditions are today, look at what happened yesterday. Add in any irrigation or rainfall, subtract the water that the crop used. So normally you would enter information every day, what the weather's like, if you get rainfall, and then the model does some calculations and estimates a lot of these things and then tells you what the conditions are today. Once you reach a certain level, then you need to irrigate. And then this is what these sensors or scheduling models, this is the kind of information to give you. A lot of times this is used for real-time scheduling, making daily decisions. Do I need to irrigate today? Can I wait a couple days? So if you're using sensors in this top graph here, up at the top, 0 means you've got a lot of water, you need to irrigate. The soil dries as the numbers go down. So every day you would follow these sensor readings. Here's 3 sensors, different depths. The black line is the average of those 3 sensors. So we would follow this line, and when it gets down to some allowable limit, this horizontal line, that means we need to irrigate. Same thing Same thing with the bottom line, you follow that red line down, when it crosses the horizontal line. A lot of people can't really do real-time scheduling, or you're not sure about this thing, you don't want to trust some model to your decisions. So another option is to do a post-season type thing, a post-mortem. Run this throughout the whole season, go about your normal operations. Put the sensors out there, collect the data, or run your model. Just do your normal operations. And then at the end of the season, go back and look and see how you did. So here, these blue bars, this is when we irrigated. It looks like here early on, well, we had a little bit of time here till it reached that horizontal line. Looks like we irrigated a little early. Where later on, where later on here, here's another irrigation. Yeah, they pretty much hit the line there. We called that one pretty good. And later on here, yeah, we did pretty good. And the scheduling models kind of showed the same thing. According to this model, yeah, maybe we could have irrigated a day or two earlier. So it's the kind of thing where you can go back at the end of the season, see how you did. Maybe there's some changes you can make for next year. But no matter what kind of scheduling you do, there's a couple bare minimum items that you really should have. A rain gauge, water from the sky is free. How much did you get this week? And a flow meter. If you're pumping water, you're using it, you're paying for it, how much are you using? Are you putting enough water out there? Not enough? Can you change your irrigation? Is there something wrong? If you know how much volume of water you're putting out, you know how big your field is, you can estimate the depth of water that you put out. So did your water run off a whole lot quicker than it used to, and you end up only putting an inch on where you thought you had 3? Or there's something not right, it takes forever to get across the field. You're putting 6 inches out. You don't know unless you measure. And then with the flow meter, you can make some changes, maybe you see some problems. So, water is an important resource. We need to do the best we can to conserve it, to use it wisely, give the plants what we need, to do it efficiently, and make sure that we have enough for the future. So we've gotten a lot of support for our irrigation and our water management efforts there in Stoneville. If you have any questions or comments, or you want to heckle or something, don't hesitate to contact me.